Here is a quick reference on common issues related to device extraction in LVS matching problems. Some of the common issues with device extraction are highlighted here. Floating bulks refer to the unconnected bulk terminals in the layout, which can cause problems during device extraction. Incorrect device type occurs when the extracted devices do not match the intended device types. Incorrect numbers of extracted devices can happen due to poorly formed recognition layers, which may result in missing or extra devices during extraction. Poor hierarchy management. This can lead to an incorrect number of extracted devices or incorrect parameter values. It is essential to have proper hierarchy management to ensure accurate device extraction. Hence, it is vital to ensure correct rules, layers, and cell names in the layout and netlist. Let's discuss some more additional causes leading to LVS matches. It is important to associate correct names with cells during extraction. Incorrect name binding of a cell or complete absence of it can lead to mismatches. Devices not properly filtered during extraction can lead to incorrect results. Other issues include device parameters are not correctly defined, leading to incorrect device reduction during extraction, incorrect PG definitions for the logic gates in the layout, or issues related to device reduction. Incorrect device reduction leads to parameter mismatches. To summarize, we had a quick overview of common issues related to device extraction in LVS matching problems and highlighted the importance of having the correct rules, layers, and cell names in the layout to avoid these issues. Check out a list of common LVS-related errors in a schematic design. Sometimes, the connections between abutments are not accurately represented in the schematic. Ensuring that all connections are correctly shown in the schematic is vital. If resistors are netlisted as generic devices, no reduction or filtering is made for them. To address this issue, use the LVS device type rule to convert the generic devices to resistors and enable reduction and filtering. If the bulk pin is missing for resistors in the schematic, use LVS delete cell pin to add it. Another issue is parasitic devices in schematics are not extracted in the layout. It refers to the presence of parasitic devices in the schematic that are used for simulation but not extracted in the layout. Use the LVS filter device rule to address this issue. Resistors must be shorted, and capacitors should remain open. If filler cells are present in the schematic but not extracted in the layout, use the LVS spice call primitive subcircuits yes command to remove them. In case-sensitive Verilog, if there are net mismatches, then set schematic case-sensitive yes to address the issue. Improper bus bits mapping in mixed Verilog and CDL netlists. This error can occur when there are buses in mixed Verilog and CDL netlists. Use the command LVS Verilog bus map by position yes instead of bit numbers to map bus bits by position if parameter mismatches exist in fill or decap cells on the top level. Use the command LVS break ambig max all to increase the comparison runtime and resolve these errors. If there are additional Verilog files from different partitions, provide power connections using the schematic path command to specify where to connect tie 0 and tie 1 nets. If nets in the schematic do not connect internally but need to be connected for comparison purposes, use the command LVS join nets to connect them. In summary, we have analyzed a list of common errors in schematic designs and solutions or commands to address each error. It covers issues related to connections, netlisting, bulk pins, parasitic devices, filler cells, case-sensitive Verilog, bus bits mapping parameter mismatches, additional Verilog files, and net connections. If PVS Pegasus gets stuck during extraction, set the PVL rule, LVS find shorts no, to disable the short finder. You can still use the interactive short locator if needed. Additionally, unblackbox L-shaped partitions and remove them from H cells to free up resources. What to do if PVS Pegasus gets stuck during comparison? At the block level, flatten the subblock where PVS Pegasus is stuck. At the top level, check if something was uniquified and if there is no empty subcircuit defined while the full layout view of the cell is available and not blackboxed. Also, check LVS.rep file for power shorts. Using these tips and tricks, you can significantly speed up your LVS runs and make the process more efficient.